Hello, my name is Santiago. I'm a researcher here for the Center for Data-Driven Discovery at Caltech. And I'm going to give you an intro to data visualization as part of the methods for computational science. Let me start by showing you an animation of a series of illustrations that Galileo did of sunspots about 400 years ago. While he did not have the technique to actually do an animated GIF like we're showing here, he did have a series of renderings, which basically you could do a flipbook style animation out of it, and it shows very well the movement of these sunspots as the days go by. This is a really good example to show the close relationship between science and data visualization to understand complex data. So today, we're going to be covering topics that hopefully help you start all your scientific endeavors, let you know where to turn for tools, and finally, let you realize what you need to maximize the results. We're going to be doing this in 6 sections. First of all, we're going to cover the terms of what is visualization, so we're all talking about the same thing. We're going to try to understand the landscape of visualization. Then we're going to talk about the different tools available. And then finally, we're going to end this first part by talking about different ways to represent your data and principles of data representation. We'll go into a detour about how to use color, as well as how to map many data variables into one single data point. The last 2 sections cover how to address bottlenecks as your data grows in size, and finally, how to put it together, and we'll see an example of an actual visualization work that we did. So let's start. What is visualization? In its simple form, we could say that visualization is anything that translates data into a more understandable format. While visualization has the word visual in it, it doesn't necessarily just cover visual displays. In fact, there's lots of work being done into using audio, sound, sonification to actually map data. You can also use haptic feedback. In this case, I'm showing a small USB device called the GeoMagic Touch, used to be the Phantom Omni, which lets you move around in 3D space and actually feel resistance as you move around your space. And of course, you can couple this with high-resolution display. You can add a Kinect to actually keep track of your head position. You can add a leap motion to actually keep track of your fingers and where they are in 3D space, so you can actually interact directly with the data. And finally, you can use mobile devices like an iPad to actually be able to interface with your display tool so that you can actually detach the interaction tools from the actual display. So visualization really helps you do everything from simply present your data to actually explore your data and try to learn something about your data. Everything in between, from quick viewing the data that's coming out of your simulation, creating results for publication, demonstrating to others what your data is doing, what your science is trying to demonstrate. Debugging is a big reason to actually do visualization, understanding if the results from your simulation are actually coming as you expected. And of course, analysis and trying to find very specific things about your data by interactive probing or data analysis tools. So that begs the question, really, how hard is to visualize data? So let me show you an example of an artist. His name was Evan Roth. He was actually on a flight, and he was sitting on his seat, and he was looking around, and he saw his tray, and he realized that he had a SkyMall magazine. Well, what Evan Roth decided to do is he decided to actually tear out the faces from the SkyMall magazine, and he laid them out neatly in his tray. His first approach was to actually put the faces by size from left to right, actually creating a visualization of his data. In this case, the data are actually the head sizes. Being an artist, he has a good concept of layout, of negative space, how to actually convey the information. And we actually get to see the whole data set. Now, in and of itself, this actually doesn't tell you too much about the data. But if you start rearranging the data, he came up with this other visualization where he separated men from women. So just from this other version of visualization, now we can see very clearly that the number of men is much smaller than the number of women represented in the SkyMall magazine. Next, he decided to actually lay out the faces, his data, by arranging them by hair color. Black hair color, darker hair color on the left, going towards blonde and white hair on the right. Again, there's not much of a story being told here, but it is a way to display your data and organize your data. Finally, he decided to divide his data between minorities and white people. Now, all of a sudden, the same data that we were looking at before, just by simply changing position, the way we arrange this data, now it's telling a very clear story. Now, I should say that SkyMall magazine actually went bankrupt about 2 months ago. But it's very clear that the representation in SkyMall magazine between minorities and non-minorities, or the majority, is actually very striking. So visualization, just with a little bit of work, can actually tell a very clear story. And that's something that we have to address as we work on our visualization. What is the story that we want to tell? What is it that we're trying to address?